So now this video discusses about what we get as the differentiation notations. So what are the differentiation notations? Differentiation notations, these are the indicators of the differentiation process, and we call them as differentiation operators. These are the actual indicators of the differentiation process. Let's say we have a function of f of x which is equal to y. And now the derivative of this function with respect to x will be now expressed as this. First of all, we should have that this is the same as y prime, that is the derivative of the function. We also have it as f of x prime, that is the derivative of the function, and which is also the same as dy over dx. That is also another actually differentiation operator, or we call it as the differentiation notation you can use as well. Apart from that one, this is also the same as having it as df of dx, and mind you, y is the same as f. In other words, having f of x is the same as should be y. So that is the same as having it as df over dx. And that is also the same as having it as d of dx, of f of x. That is the same as that. That is another notation. Also, you can also use this one as well. d, of f of x. That is another notation where capital D corresponds to the derivative of the function f of x. And also, this is the same as dx of f of x. So these are the typical differentiation notations that you need to understand about. So you have, a y prime, f of x prime, dy over dx, df over dx, d over dx of f of x, or capital D actually f of x, or dx of actually f of x. So these are the notations you just have to get much in mind. So what if the function is differentiated, let's say twice? That is the high order derivative. So how should you have the notations corresponding to the high order derivative? If the function is to be differentiated twice, we'll have it as y double prime, which is the same as f of x, a double prime. And of course, this is also the same as, d2, d square y over dx square. This is also the same as having it as, d should be d square f, and that divided by dx square. So which means this function is being differentiated twice. That is the second order derivative. And this is also the same as d square over dx square of f of x. And also this is the same as, having it as somewhere about d should be d of f of x. And of course this is the same as also dxx of f of x. These are the typical notations you just have to get. Likewise, what if we have the third order derivative and also the fourth order derivative? How the notations will be. So try to have that on at your own time. And now, for instance, let's say if we have, let's say, a function f of x which is equal to y, and let's say we should have the derivative of the function at the value x is equal to a. So how should we use these notations? And for the derivative at the value x is equal to a, principle remains the same. Or have, f of a prime. You can use that one, f of a prime. We may also say, you can use that of f of a prime. And of course, this is also the same as having it as about, let's say, should be a d of a of x. That is another notation you can use to have that one. And otherwise the other notations might not work to present them as that, but we should have that. Or else this notation can also be used. Let's say if you are to use the other notations, let's say for instance you can have dy over dx, a stroke x is equal to a. So which means you are to evaluate the derivative of the function at x is equal to a. So a can be any number, can be x as 2 or whatever. Or else we can have it as, let's say, else you can use this other notation, that is dy over dx, somewhere about should be x is equal to a. That is another good notation that you can use. Likewise, let's say if we have something about, you can also have, let's say, a d of should be f of x, sort of x, let's say, is equal to a. That is the derivative of the function, where we should have to evaluate the x as a. Or else you can also use this one as well. Let's say if we have dx of f of x, that is x is equal to a. That is also okay, you should have that. And let's say if we have something about, you can also have this one as well. Let's say if we have d over dx of, let's say, x is equal to a, that is also a part of the game that you can use as well. In the first instance, let's say if we have a function, let's say f of x is equal to, let's say, 2x squared, let's say minus 1. Now evaluate, let's say, dy dx, dy over dx of, let's say, x is equal to, what is that? So which means this is the same as having it as f of 2 prime. That is the same as that, of which you can be able to have that understand. And how about, let's say, if you want to have this, let's say d2i over dx squared, that is the same as, we should have x equal to, this is the same as having it as f of 2 double prime. That is the same as that. So these are the actually differentiation notations that you need to understand when it comes to the actually differentiation case. Thank you.